Hey class, today we're going to go over the worksheet that you guys did in class. Remember, this was a completion worksheet. I'm going to go through the answers and then my explanation of how we got those answers. If you want to fast forward to any of the problems that you struggled on and listen to the explanation, I highly suggest that you do. And so we're just going to kind of go back and forth. On number 1, you should have gotten a plus 3. Now the way that we figured out a plus 3 is that this is a neutral compound. So this is going to actually be equal to 0. And then we have to look through our rules. Do I have a rule for sulfur or oxygen? And I actually have a rule for oxygen. It's rule number 5. It says typically the oxidation state is -2 unless it's bonded to fluorine, a 1A or 2A metal, and it's not bonded to any of those exceptions. So here we're going to have 3 oxygen with an oxidative state of -2. Now we got to figure out sulfur. Now there are 2 sulfurs and I do not know it, so I can just write 2x. From here we just use algebraic to solve. 2x minus 6 equals 0. We're going to get 6 to the other side and divide by 2, so x is going to equal a positive 3. If we look over here on number 7, we have a single element, which is cobalt, and here we're looking at our charge for cobalt. For this one, this just follows the rule for number 6 that says a monoatomic ion, so a single ion, will have an oxidative state equal to its charge. So its charge is +2, so that is going to be its oxidative state. Down here for number 2, we got FeO. If we look at this for number 2, we should have actually gotten a +2 charge. Now, the way we could find this is a couple different rules. Remember, this is neutral, so this is going to be equal to 0. The rule for oxygen is that it is equal to -2 unless it's bonded to fluorine, a 1A or 2A metal. It is not bonded to the exception, so oxygen is actually going to be a -2, and there's one of them. And then iron, I don't know. Here we can add 2 to the other side, and that's how we get a +2 charge. The second way that you actually could have solved for this is following rule number 7 that says metals of ionic compounds are equal to their charge. So we could have actually uncrossed these charges and saw that, oh, -1, +1. Well, oxygen's never a -1, so it's actually -2, which means this should have been a +2. These 2 charges were reduced. If we look over here at number 8, this is where we see a little bit of a difference. We have 2 elements and we have a charge. So we actually cannot set this to 0. We must set it to a -3. Then we look at our rules. Do we have a rule for phosphorus or oxygen? I only have a rule for oxygen. It is not bonded to any of the exceptions, so it is actually following rule number 5, stating that oxygen, which I have 4 of them, will have an oxidative state of -2. And then phosphorus is X, since I have 1 of them. From here, you get X minus 8 equals -3. We're going to add 8 to both sides. And so for number 8, you should have gotten +5 as your answer. Now we're going to go down here to number 3. Number 3, we have HNO3. This is neutral, so we're going to set this equal to 0. Now I have to look, do I have a couple of different rules? The first rule that we're going to notice is that we have a rule for hydrogen. Hydrogen's rule is number 4, and it states that if it's bonded to nonmetals, its goal is going to be a +1, which nitrogen and oxygen are both nonmetals. So we have hydrogen as a 1. We do not know what nitrogen is. And then oxygen is a -2, and none of these are exceptions. So we actually have 3 of them at a -2, which gets me a -6 here. Now here, if I combine like terms, x minus 5 equals 0, and then what we can do is we can add 5 to the other side, which is how I get a +5 as my answer for number 3. Over here, this is where we have to make sure that we are double checking our oxygen. So a lot of times people often say, okay, this is equal to 0, which it is, that's a neutral compound, but they want to mistakenly give oxygen a -2 charge here. But double check that it doesn't fall within exceptions. Rubidium is actually a 1A metal, so it falls under an exception. And there's a rule for everything in group 1A, and the rule is it is always going to be a +1. So rubidium is a 1. Oxygen, there's 2 of them, so we have 2x, and from here we can actually solve, subtract 1 to the other side, and then divide by 2, and you actually get a -1/2. This compound right here is actually an example of a superoxide. For number 4 down here, we should have actually gotten the rule +1. We didn't have to solve anything for this. Hydrogen has a rule that states when it is bonded to a nonmetal, which sulfur is a nonmetal, it's always going to be a +1 charge, and so I don't have to solve for anything. For number 10, you guys should have gotten a charge of 0. This actually follows rule number 1. We have a pure element right here, has no charge on it, and so since it is a pure element, the oxidative state is 0. For number 5, we have OF2. This is another example where we kind of have to be careful with our oxygen. A lot of people will mistakenly give this a -2 oxidative state. However, it is bonded to fluorine, which is an exception. So if we actually equal this to 0, since the charge is neutral, we have to figure out what fluorine is since it's the exception. If we look at rule number 3, it says fluorine will always be a -1. And I have 2 of them, so that's going to give me a -2 right here, and oxygen is going to be an X. So when I add 2 to the other side, I end up getting X equals +2. This is one of the only rare exceptions where you're going to see oxygen have a +2 oxidative state, especially since it's such an electronegative element. Number 11, here we have oxygen. Again, we must be wary of our oxygen. Notice that it's typically -2 unless it's bonded to a fluorine, 1A, or 2A metal. Here we should recognize that barium is actually a 2A metal. So when I look at barium, it actually has a set rule, and that is rule number 2. Everything in group 2A is always going to be a +2 charge. Then I have 2 oxygens, and I don't know my oxygen, and this is all set to 0 since this is neutral. From here, we can subtract the 2 to the other side and then divide by 2, and you actually get a -1 oxidative state for oxygen, showing that this is actually a peroxide. Number 6. Number 6 is special because you can actually solve it 2 different ways. One of the ways is you can actually look at rule number 8 that says halogens are typically going to be a -1 unless another rule applies. The other way that we could look at this, if you don't want to look at that rule, is by looking at rule number 7. Rule number 7 says if it's an ionic compound, they're going to be equal to their charges. So this is actually an ionic compound because we have a metal, which is chromium, and then the nonmetal, which is chlorine. We can see here if we uncross the charge, chromium has a 3 charge. Then you get a 3x equals 0. When you go to solve this, you actually still get a -1. So it doesn't matter which way that you solve it. For number 12, this one is a little bit special case as well. There are 2 different ways you can solve it. No matter what, you are actually going to end up with a +4. So I'm going to show you the 2 ways that you can solve it. The first way is by using the rule number 7 that says metals of the ionic compound tend to have the same oxidative number as their charge. So here, if we look at this, we uncross our charges, we're going to notice that they're simplified. Carbonate should be a -2 according to our chart, which means copper should have been a +2 because these end up getting reduced. So we end up getting copper's a 2. We don't know carbon. and then we have carbonate. Now oxygen is going to, there's 3 of them, and then it's going to be a -2 because it's not bonded to the exceptions. From here, this is going to equal 0, and then we can go ahead and we have 2 plus x minus 6 equals 0, combine like terms, and then when you add, you get a +4 on the other side. The second way that you can actually solve for this is to pull out this polyatomic right here. You can actually pull out this carbonate or any polyatomic that you have, as long as you remember to set it equal to the charge. So I can actually set this equal to -2. I can recognize I have 3 oxygen at a -2 plus carbon. From here you get x minus 6 equal -2. Add 6 to the other side, and you still get a +4. So that's kind of what I like about polyatomics, is you can actually pull them out and solve for them individually as well. Number 13, this is a single element, has no charge, so it's going to be equal to 0 according to rule number 1. For number 17, this one we have to piece together some rules. So here, magnesium is a group 2A metal, and it has a definitive rule that it is always going to be a +2. We don't know our sulfur, so it's always going to be X. And sulfur also, fluorine has a definitive rule. Fluorine's rule number 3 states it will always be a -1, and I have 6 of them, so we're going to type in a -6. This is all going to be set to 0 since its charge is 0. When I look at this, we end up combining like terms, and then when we add 4 to the other side, we end up getting a +4 oxidative state for sulfur. Down here for number 14, this is where we're going to have to watch out and make sure that we're watching this oxygen. This is all going to be set to 0. Now oxygen is bonded to a 1A metal, so we have to see that we are bonded to an exception. And so we must solve to make sure that this is not an oxide, peroxide or superoxide. So according to the rule, potassium, I have 2 of them, and the rule states that it is always a +1. And then we only have 1 oxygen. So you end up getting 2 plus x equals 0. And you can actually subtract that 2 to the other side, and you get x equals -2. This is an example of where, even though this is bonded to a group 1A metal, it's not a peroxide and it's not a superoxide. It just follows the regular rules, but you always want to make sure you double check. Over here, we're going to set this equal to 0. And then fluorine has a hard and fast rule. Rule number 3 states that fluorine will always be a -1. And I have 4 of them, so I'm going to type a -4. I have 1 carbon, and then to set this on the other side, carbon will be a +4 over here. Now on to our last 4 that we kind of have. This is where I gave you some more practice with things that have charges. Here I have iodine and oxygen, and notice I have a charge here, so I cannot set it equal to 0. I must set it equal to -1. I do not have a hard and fast rule, except for a lot of people often mistakenly say that iodine has to be -1 based on rule number 8. However, rule number 8 says halogens are -1 if no other rules apply, and unfortunately there is a rule for oxygen, so we must apply oxygen's rule first. I have 3 oxygen, and here oxygen is going to be a -2. It's not bonded to the exceptions, that's why. And then I have 1 iodine. From here we get x minus 6 equal -1, and we're going to add 6, and we end up for number 15 getting a +5. Over here, ClF3, this is again where we have to pay attention to our halogens. A lot of people mistakenly say that, oh, chlorine is a -1, but that's only if no other rules apply, and unfortunately there is a rule for fluorine. Fluorine states that it is a -1, so I have 3 of them. That gives me a -3 plus x because I have 1 chlorine. When you add the 3 to the other side, chlorine here ends up being a +3. Over here, we have bromine and BrO2 minus 1. We have a charge, so we must set that equal to the charge. And then again, halogen rule. Since another rule applies, we have to apply oxygen's rule first. Oxygen's not bonded to any of the exceptions, so we have 2 oxygen that has a -2 charge. We have 1 bromine, so just a 1x. When we solve, we get x minus 4 equal -1. Add the 4 to the other side, and for number 16, we actually end up getting a +3. And let's move on to our final one, HBrO3. Again, we're going to piece together rules here. Hydrogen has a hard and fast rule. Hydrogen's rule is that it is a -1 when bonded to a metal, but it is a +1 when it's bonded to a nonmetal, which it is. So we end up getting 1 plus, I don't know my bromine, because even though it's a halogen, oxygen has a rule that must be applied. Oxygen's rule, it's a -2 unless bonded to one of the exceptions, which it is not. So here, -2, and I've got 3 of them, gives me a -6. Set that equal to 0 since this is neutral. We combine like terms, x minus 5 equals 0. We're going to add 5 to the other side, and you end up getting a +5 as your final answer. Now these are a little bit tricky, so please listen to the explanations if you missed any. I'm going to give you more practice today, and you'll have today and the following class period to work on it and ask any questions that you want. And I've also kind of linked an online way to get more practice as well. I hope you guys have a great day, and I'll see you next time.